Hello, this is Raden Wijaya again. Before we start our video, I'd like to inform you some warning regarding this video. First, if you really love Sudoku, I don't think you'd want to finish this video, because in this video I will give you an algorithm on how to play Sudoku. And Sudoku is really addictive and I used to love it very much. However, now I don't really play it, because after I discovered that we have an algorithm to finish the Sudoku game, I become disinterested in the game. If you continue to watch this video, I will ruin Sudoku for you, and stop watching this video if you don't like it. We will begin by explaining the game of Sudoku. Sudoku is a really simple game and it was meant to be played on pen with paper. However, nowadays digital version does exist. The game consisted of a grid with an area of 9 by 9, and these grids are partially filled with numbers. Your task is to fill in the blanks with the unique numbers between 1 to 9. However, there are certain rules that you must follow in order to win this game. I will explain it on the next page. The Sudoku board is split into 9 units of 3 by 3 subsquares, and I will name the subsquares from 1 to 9, with subsquares number 1 is in red. The number in each row, columns, and subsquares must be unique, so you cannot repeat the number from the subsquares. Now a little bit of history on how I play Sudoku. I've devised the algorithm to play Sudoku like long time ago, and actually I found it quite successful in playing Sudoku, and I can play a lot of Sudoku on my mobile phone before, and it's pretty good. And then I implemented in the computer program, and the source code was originally implemented in Turbo Pascal. However, I've adapted it to Delphi 10.1 Berlin for this video. The algorithm is fairly simple, so I will need to select a blank location. For example, I want to select on the center, row number 5, column number 5, okay? And then find a number that are in the column and rows and the subsquare of the position I wanted to, and I'll save it. I can memorize because it's only like 10 numbers, it's very easy. And then I'll find the candidate for the answer, and then if I only have one candidate, then that must be the answer. If there are more than one, then that grid is not workable, so I will move to another grid. I will repeat this process until all the blanks are filled. It was pretty straightforward and was pretty easy. It's not hard at all. On the right side, you will see the Sudoku board. Let's say I want to fill location R5C5. Okay, we can see that row number 5 got 2, 3, 4, and 5. Column number 5 got 6 and 9. And subsquare number 5 got 1, 2, 3, 4, 5, 8. The only number that is not listed is 7, so the center location must be 7. We have found one missing number. Cool. Let's say now you wanted to fill the other grid. For example, row 5, column 4. It's still on the subsquare 5. We got like 1, 2, 3, 4, 5, 7, and 8. And column number 4, we have 1, 2, 3, 9. Row number 5, we have 3, 4, 5, 7, and 2, of course. So the only number that is not there is 6. So the blank row number 5, column 4 must be 6. Repeating the process on column 6, row 5, we can conclude that it must be 9. So I'll put 9 there, and now we will focus our attention on column 7 and row 5. It could be 1 or 8. There is no way we can know. It's easy. Just leave it. Just memorize. Column 7, row 5, 1 or 8. And we'll find easier prey, such as column 2 and row number 5. Row number 5 and column number 2. This grid is a lot easier to solve than row number 5 and column number 7. Why? Because on column number 2 we have 4, 8, and 9. we have 8, while on row number 5 we have 2, 3, 4, 5, 6, 7 and 9. So from row number 5 we have 7 numbers, and from column number 2 we have one number, 8. So total we have 8 numbers, only 1 is not on the list. So there you go, row number 5 column number 2 must be 1, and we can deduce that row number 5 column 7 will be 8. So this is how the algorithm works. Just repeat until all the locations are filled. Very easy. It's perfectly doable by hand because this algorithm was made with hand. It was not designed for computer works. So let's go to the next slide. We'll come to the computer, how the computer handle this algorithm, how this algorithm implemented. The input and the output condition. Okay, it was simple text file containing a grid with the numbers 9 by 9, each number separated by space. And for the input I'll use 0, and 0 means blank. So if on 0 it means like the grid is still empty. But the output, it will consist the same with the input. However, it will have no more blanks because all the number is filled. These are the variables that I put on the source code. So R, C and I. No, it's not residential, commercial and industrial. No. R and C will denote the row number and column number, while I is used to point the candidate array, the key of the candidate array. For example, like on the example before, on row 5 column 7 I have 2 candidates. One is 1, the other is 8. Okay, 8. I will point, when I is 1, it will point to the number 1, while I is 2, it will point to number 8. That's how I used. While phi is used to hold value, phi value. Okay, and now we have count and before count. Okay, it's not very intuitive name, I know, but count will record the number of steps taken. For example, like there are 20 blank spots, the count will be 20, and the before count is the number of blanks before the algorithm run. So I have to calculate between count and before count. I'll compare them. If count and before count remains equal after the algorithm run, it means the algorithm cannot be solved by the the sudoku cannot be solved by the algorithm. If count reaches 0, it means there are no more blanks. The sudoku was solved. Simple as that. Data variables is a 3-dimensional array of row, column and candidate numbers. Those are pointed by R, C and I. Data on 0, for example like R, C and 0, is the actual value of the sudoku number. It's also the solution of the sudoku. However, data RC from 1 to 9 are the candidates. So if there are no more candidates, if the sudoku is solved for that particular grid, there are no 0 to 9, just only data RC 0. Well, the other variable is row, col and squares. It consists of the data stored, that is what is existed in that row, column or sub-squares that we are currently working with. For example, like in this row we have number 1, 2, 5, for example, like that. It was stored in an array format with index of numbers. Yeah, Turbo Pascal is support numbers, and it will make Boolean. It was made like that so the program can access it very quickly, because accessing number array is only 0 1 complexity, so it can be pretty much instantaneously instead of if I use linked list or any other data types. This is the fastest. And then I will explain you about the functions. For example, the first function is remove candidate. Okay, it will use to search the candidate on the stack. You know, the stack that I'm talking before, like RC and I, yeah, data RC and I. For example, I will remove candidate number 1. Okay, it will delete candidate number 1 and the pull the stack, for example. So candidate number 2 become number 1, number 3 become number 2. This one is complexity is 001, actually 09, but yeah, it's not very fast. And I will have add candidate. It will use to put candidate number on the stack. Get v value. This will be used to find the square number, sub-square number. If you have a sub-square, for example, I have a row number 3 and column number 7. What is the sub-square number? I will just get v value. And I have said before, we have a row, column, and square data. To check whether data exists on that row or on the column or that square, we will use this is row exists. So if I put the value v on that row, it will check on the variable. It's working very fast and O1 complexity is very fast function. And we have initialize with it will be called every time the main loop repeats. Before analyzing and before solving, it will initialize the row, column, and sub-square variable. Now I will discuss about the two most important functions of the source code. First, analyze. It will visit each and every part of the grid, every row, every column, and it will record the possible candidate for that grid. And solve, of course. It will also visit all the grid. When it's blank, it will fill it with candidate, but it will only fill with candidate when there is only one candidate. Then it's surely the correct answer, as the algorithm says before. I know we come to function main. It's main code, the last begin and end. If you don't know, in Pascal, is the main doesn't have name function main. It's just like the begin and end, but with dot at the end of the end. Okay, it will read input, prepare output, and this is where the main loop is located. And the main loop will run and analyze for several times until there are 0 blanks, until the count is 0. That's it. Okay, let's begin by looking at the source code. Here is console apps. You have the data, as I say, that row exists, call exists, get v value, and square exists. You have init data and add candidates and remove candidates, analyze, solve, and this is the main loop. Yeah, with screen recognition of Pascal, and we'll assign and default everything, and this will, if count equals before count, and we'll have here, see, this is the condition used to check if count equals before count, it will stop, and if count less than or equal to 0, it will also stop. So if count is equal to before count, it will be unsolvable. And we'll have like R1 to 9, and this one is the output writing that we'll use to write the output. I'll show you about how this perform. I'll have a sudoku. This is the same sudoku as the example. Okay, it's there. I'll run it. Done. And I have the output here. See, this is the answer of the sudoku. And let's say we want to use other sudoku. This one, I'll copy it up here. Okay, this is 6209 saved file. Run it again. Done. And we'll have the output here. Perfect output. Hope you understand and you like it. There are still some sudoku that cannot be solved by this algorithm. There is a sudoku with too small numbers. The number is too sparse, the grid is too empty, then this algorithm won't work. Because computer is not human, it's not intuitive, it's not creative. So to improve this one, perhaps in the future I can have some iteration of this algorithm that will spawn a random number at certain location and then run it again. If it doesn't work, I'll respawn random number at certain other location or at the same location but different number and run the algorithm again. It might work, but it's still it might not work. But yeah, but it will definitely improve the probability that of the number of sudoku that can be solved. Now you know the algorithm of how to solve sudoku and you cannot unlearn it, and then I think you will use this in your game and you will have less fun with your game, and during this quarantine time you'll have less game to play. But I think you can add some creativity to it and you can beat the computer. So I'm sorry for ruining your hobbies, but you see the source code on the description below. It's in Turbo Pascal code. I will hope you still can convert it to Delphi on your own and try to run it. And good luck and have a nice day.